Hello, welcome to Some Griffin's occasional series of Matlab tutorials. Today we're looking at the week 5 problem that we have. So you have the notes in front of you, and we're on the maths tutorials, and we're on page 28. So I did this before, but I'm just going to repeat it because I'm just making reference to the notes. So we have the classic fluid tank problem, and so you have the height. Obviously the amount of water flowing out is proportional to the height. So you have the HDT here, so that's the output flow, and then also we have here an input flow, and we're giving some initial conditions here. So what we have then is we have the rate of change of height with respect to time is the input flow minus the output flow. The code is given for you there, and can I just say, if you cut and paste from the PDF document into the Matlab editor, be careful of the single quotes and the double quotes. They look like single quotes, they look like double quotes, but they're not. You have to type them in manually. So we have the function here, we have the HDT here, we've named the function, and we have it in here. So let's look at it. Yeah, I've written it up in Matlab. So there is tankfill.m, just as per the notes. It's very simple. Just one or two things to note here. The name of the function is tankfill. You've got to name it. I don't know if you can see it, but you've got to name the function the same as the function name. If they're not the same, it won't work. So if you've called the function tankfill, you've got to save it as tankfill. There's the input, there's the output, and there's the HDT, so you've defined the function. Let's go back to the notes. Very simply here, I've done a little bit, we're just doing 0 to 30 seconds. We've given the initial conditions, and then you solve it using ODE 45. I would have done it very slightly different. Here, the function is given in single quotes. Now again, can I emphasize this? If you copy and paste that into your Matlab editor, it looks like single quotes, but they're not. How did I do it? Ever so slightly different. So I gave it up here, a typical one here. So double, all these single percentages are comments, and a double quote will give us a table of contents if we publish it, but that's not for today. Same thing here, ever so slightly. I have to find the function name as tankfill. I've just put it in there. The time span, that's my integration range, is 0 to 30, and H0 is the initial condition. I run ODE 45 and I plot, and if I just run that there, I get that. And as I said in the comments, now this isn't a great graph, so when you're doing it yourselves, you would put in an x-axis, a y-axis, and the other thing, it's a little choppy, so what you could do here in the time span, you could say 0 to 30 in smaller increments. And we do it in smaller increments, we might get a more smooth graph. You can see there it's a bit, I use the word choppy, it's a bit straight liney, so if we broke that up, you would get it better. So you can ask me in class how to do that. Okay, so thanks very much for listening.